Okay, here's another mirror problem. Again, here are all of our sign conventions. Here are all of our equations. We've got a makeup mirror that produces a magnification of 1.35 when some object is 12 centimeters away. Now, they don't specifically write it in words here, but what they mean by this is an upright image. A positive magnification means your image is upright. Negative means it gets inverted. So our height of the object and of the image are both positive. Both of these must be positive for the magnification to be positive, which tells us our image and object are going to end up being on opposite sides of the mirror. Now, we don't know at this point if we have a concave or a convex mirror, but let's draw it out and we'll figure that out. So here's my object, and it is going to turn out that we have a concave mirror because I know the answer. But let's say we didn't know, we would have some mirror here, and then we'd have some object that's also upright. And again, I already know because I've worked out the problem that it's going to be on the opposite side. But we don't actually have to know all that to begin with. What we do know is that the magnification is the opposite of di over do. So di, the distance between the object and the mirror, is 12 centimeters, and the magnification m is 1.35. So we get 1.35 equals the opposite of di over 12. So di will be negative when I move the negative over 12 times 1.35, which you could type that in your calculator, will be negative 16.2 centimeters. Remember, when we're talking about distances for a mirror, the side with the object is the positive side. The other side of the mirror is negative. Any distances over here are positive. Any distances over here are negative. On both sides, anything above the axis is a positive height. Anything below is a negative height. Upright objects and images are positive. Inverted heights are negative. Okay, so now that we got DI, we know that the image has to be behind the mirror. And then we can find F using 1 over DO plus 1 over DI equals 1 over F. So that'd be 1 over 12 minus, because DI is negative, 1 over 16.2 must be 1 over F. And you type that all in your calculator and you will get F equals what we have up here, 46 point, let's say 29 centimeters. Because F is positive, that means we must have a concave or converging mirror. Concave mirrors are converging, convex mirrors are diverging. And again, what do we mean by concave? It means your object is inside the cave. The mirror wraps around your object. And my focal point will be over here, somewhere back behind the image. And there are a bunch of rules you can memorize that for a concave mirror, if your object is in some certain range, you'll end up with a virtual image. And if the object is out here somewhere, you end up with a real inverted image. There are a whole bunch of rules you can memorize. I've never bothered to memorize all of those rules because it's so easy just to plug and chug and see. And like I'm going off memory here, but I think it's if your image is halfway between the focal point and the mirror or closer. For a concave mirror, you end up with a virtual image. Don't quote me on that. There's some formula you can memorize. I've never bothered memorizing it. Okay, that's a good place to stop on this one.